Welcome to Build Mystery, the channel where engineering meets imagination and every machine has a story. From the precision marble cutters of Biros Hellenic marble to the revolutionary plastic-to-block technology of BiBlock and the unstoppable flow of water through C900 Trans 21 pipes, we reveal the hidden genius behind the machines shaping our world. From towering precast structures to eco-friendly innovations, from advanced construction platforms to high-performance materials, every creation is designed to amaze. Hit subscribe, tap the like button, and share this journey with anyone curious about the power of technology. Step inside the world where engineering becomes art. This is Biros Hellenic Marble's cutting powerhouse, engineered in Greece to turn massive raw marble blocks into flawless, polished slabs with unmatched precision. At its heart, massive bridge saws and high-speed cutting lines spin diamond-tipped blades with relentless force, guided by advanced CNC automation that calculates every motion down to the millimeter. Hydraulics deliver immense torque, sensors monitor every movement, and water jets cool the steel as it carves through stone. Raw blocks enter the line, and perfect slabs emerge, trimmed, polished, and ready for any project. Every cut is optimized, every surface engineered for quality, transforming ancient marble into modern craftsmanship. This is industrial precision meeting timeless stone, marble mastery powered for the world. This is BiBlock, a building block born from plastic waste and engineered by Bifusion, a company rewriting the rules of recycling. Plastic that used to clutter landfills and oceans is fed into a patented steam and compression blocker system, where shredded, unsorted waste is fused into durable construction-grade blocks without glue, chemicals, or sorting. The result, solid interlocking BiBlocks that match the size of concrete units but weigh less, resist cracking, and install fast with no mortar. These blocks cut CO2 emissions and build time, turning trash into walls, fences, shelters, structures that are strong, sustainable, and built for tomorrow. Waste becomes infrastructure, powerfully, precisely, permanently. This is C900/Trans 21, a next-generation PVC pressure pipe engineered by Diamond Plastics for water transmission and distribution with scale and endurance. Built to the AWW AC900 standard, these pipes span from mid-size to massive diameters, carrying potable water, sewer force mains, and irrigation flows with unmatched reliability. PVC material gives corrosion-free strength that resists soil chemistry and rust like steel, and cast iron can't. Integrated gasketed joints lock tight under pressure, while precision-manufactured walls stand up to hundreds of PSI without yielding. Smooth internal surfaces reduce friction and pumping losses. Every length is hydrostatically tested before it ships, proving performance before it ever sees the field. Long-lasting, flexible, and engineered for modern infrastructure, this pipe keeps water moving where it matters most. Durable, leak-resistant, and built for the 21st century. Infrastructure engineered for tomorrow's world. This is IPSIIS, a French clean-tech innovator, turning recycled minerals and industrial byproducts into non-combustible, high-performance insulation and refractory foam that protects buildings and industry at extreme temperatures. Founded in 2014, IPSIIS engineers lightweight mineral foams that combine thermal insulation, fire resistance, and environmental sustainability in a single material, porous, rigid, and exceptionally effective without petrochemicals or toxic additives. The process mixes selected mineral powders with water and natural additives, creating a foam that traps air and resists heat well over 1,000 degrees Celsius. while slashing carbon footprint and energy use in production. These foams are produced with low capital cost and local resources, transforming waste into durable insulation and fire protection for walls, industrial equipment, and infrastructure. Sustainable materials engineered for safety and performance. This is ABM Arch, a precast bridge and portal frame system engineered by ABM Mosti, a civil engineering innovator redefining infrastructure across Europe. These massive concrete arches and frames are designed off-site with precision, cast in controlled factories, and delivered ready to install, eliminating the delays and risks of traditional in situ construction. Precision-engineered components fit together like giant mechanical puzzles, interacting with soil and backfill to create bridges, underpasses, and load-bearing structures that are lighter, faster to install, and more durable than conventional builds. ABM's system maximizes strength through geometry and material science, accelerates project timelines, and slashes construction impact on site. These precast units arrive ready, slot into place with engineered accuracy, and create infrastructure built to last over a century under heavy loads and harsh conditions. Civil engineering, engineered for speed, strength, and longevity. This is SIKA ComfortFloor, a precision-engineered impact sound insulation system from SIKA that transforms how staircases connect to buildings. Designed for modern construction, Tronsol inserts engineered elastomer and load-bearing elements between stairs, landings, walls, and slabs to decouple structure and dramatically reduce impact noise where footsteps would otherwise travel through concrete. Tested to building standard acoustic methods, Tronsol achieves high sound insulation levels without bulky add-ons, sealing joints against acoustic bridges while still transferring structural forces where needed. Its modular elements fit straight and spiral stairs, prefabricated parts, and complex geometry, all while meeting fire safety and performance standards. This isn't simple padding. It's precision isolation designed into every seam to make buildings quieter, stronger, and more comfortable. Acoustic engineering built for real-world construction. This is SIKA ComfortFloor, a seamless engineered flooring system that transforms ordinary floors into continuous, high-performance surfaces. Developed by SIKA, ComfortFloor is liquid-applied polyurethane that cures into a jointless, resilient floor with virtually unlimited design freedom, from clean monochromes to custom artistic finishes. Its smooth, low VOC surface feels warm and soft underfoot while resisting wear, abrasion, and heavy foot traffic in hospitals, schools, offices, and public spaces. ComfortFloor reduces impact noise and echoes thanks to its resilient chemistry, enhances indoor air quality with extremely low emissions, and creates a hygienic, easy-to-clean environment with no joints to trap dirt or bacteria. Durable, customizable, and built for modern architecture, this isn't just flooring, it's engineered comfort for every space. Seamless strength beneath your feet. This is Klober Wakaflex, a precision-engineered lead-free roof flashing system that rewrites the standard for watertight pitched roofs. Designed and manufactured by Klober, Wakaflex is an extremely flexible, self-adhesive flashing with a reinforced 4-layer structure that stretches up to 50% in length and 15% in width, letting it wrap around chimneys, dormers, valleys, and roof-to-wall junctions with unmatched conformity. Unlike traditional metal or lead flashings, it self-welds on overlaps, creating an instant, impenetrable seal that resists wind, rain, and UV exposure without specialist tools or heat. Lightweight, non-toxic, and durable with decades of proven performance, Wakaflex cuts installation time, eliminates corrosion and theft risk, and protects every vulnerable roof detail with seamless, weather-tight precision. Roofing engineered for strength and simplicity. This is Titan Floor, a precision-engineered raised access flooring system built for modern infrastructure and industrial demand. Designed and manufactured by a leading Chinese specialist in raised floors, Titan floor panels and pedestals create an elevated floor surface that hides cabling, wiring, air distribution, and utilities beneath your feet in offices, data centers, clean rooms, and commercial spaces. The system uses steel, calcium sulfate, aluminum, and anti-static panels, customized for load, function, and environment, engineered to resist static, fire, wear, and impact, while enabling swift installation and maintenance access. Every panel snaps into place with engineered tolerances, keeping floors level, durable, and easy to reconfigure as needs change. Engineered around automated production, quality certification, and decades of refinement, Titan Floor turns complexity into structured simplicity. Infrastructure engineered for adaptable strength and seamless performance. This is Alfred Miller precast pile caps, engineered foundation power for heavy civil and infrastructure projects. Designed and manufactured by Alfred Miller companies, these massive concrete caps are built off-site in controlled conditions, then delivered ready to set on top of driven piles to create rock-solid structural footing. Precasting moves the labor out of the hole and into the factory, eliminating weather delays, reducing site crew hours, and ensuring precision alignment every time. Each cap locks multiple deep piles together, transferring enormous loads from bridges, buildings, and heavy structures down into the ground with engineered accuracy. Faster to install, custom configured to project specs, and tolerant of harsh field conditions, these pile caps turn complex, deep foundation work into repeatable, reliable results. Foundation engineering built for speed, strength, and certainty. This is Build and Lift, an innovative New Zealand construction system engineered to build roofs on the ground and then lift them into place, eliminating dangerous high work, scaffolding, and wasted time. Founded on a simple, powerful idea, the system lets crews assemble full roof structures horizontally with precision and safety, then raise them with controlled mechanical lifts into their final position. On site, heavy framing and trusses are guided into place in minutes, not days, reducing labor, cutting risk, and keeping crews out of harm's way at height. It's faster, safer, and more efficient than traditional roof-up builds, improving schedule, quality, and site safety all at once. Construction engineering reimagined to lift performance and lower risk. This is Dinsel Walls, an advanced structural walling system engineered in Australia to rethink concrete construction from the ground up. Instead of traditional formwork, lightweight interlocking polymer panels snap together on site, creating a permanent form that stays in place after concrete is poured, eliminating stripping, reducing labor, and accelerating build speed. Once filled, the concrete and reinforcement become a monolithic, waterproof, fire-rated wall with superior durability, crack control, and resistance to corrosion and concrete degradation. Certified for internal and external load-bearing use and tested under seismic fire and water pressure standards, Dinsel's impervious polymer skin protects the structure while speeding construction up to 50% faster than conventional methods. Builders can install walls quickly with minimal equipment, cutting costs, waste, and project time, turning raw concrete and polymer into stronger, longer-lasting walls. Structural walling engineered for speed, strength, and resilience. This is Mason's Enviro AAC, an advanced autoclaved aerated concrete block system engineered by Mason's Plastibrick in New Zealand to redefine how we build with concrete. These lightweight, precision-manufactured blocks combine air-entrained cellular structure with high-strength concrete to deliver walls that are up to 5 times lighter than traditional masonry, but still fire-resistant, thermally efficient, and structurally capable. Automated production and autoclave curing lock in consistent quality, while the internal air pockets deliver superior insulation and sound control straight out of the pallet. On site, blocks cut and fit quickly, reducing labor and waste, and creating airtight envelopes that slash energy use in homes, schools, and commercial buildings. Durable, dimensionally precise, and engineered for modern performance standards, Enviro AAC turns raw material into smarter, stronger walls. This is Montabaur, a living engine of history and modern mobility in the heart of Germany's Westerwald. Born over 1,000 years ago, this town runs on layers of medieval architecture, timber-framed streets, and a striking yellow castle that dominates its skyline. Its ancient walls coexist with one of Europe's most advanced transport nodes, the ice high-speed rail station linking Cologne and Frankfurt in minutes. Streets pulse with life, bridges span valleys, and every corner tells a story of resilience and design. Here, historic stone meets modern steel, and every view feels engineered for precision and place. Montabaur, where heritage and infrastructure move as one. This is FOD's Trek-Out Control System, a precision-engineered site entrance solution built to stop mud, sediment, and debris from leaving construction zones and contaminating roads. Designed and manufactured in the USA by FODS, this innovative mat replaces traditional rock-stabilized construction entrances with durable, reusable composite mats that actively knock soil off vehicle tires, protecting environments and keeping projects compliant with stormwater standards. Built from high-density, recyclable materials, each FODS mat withstands heavy loads while staying lightweight and portable on site. Installation is fast, maintenance is minimal, and the system outlasts single-use aggregates by years, cutting costs and emissions across every build. From highways to airports and heavy civil works, FODS turns environmental control into engineered performance. This is Safe Smart Access, a precision-engineered height access and safety platform system built to redefine how workers reach, maintain, and service structures at elevation. Engineered in the USA with over 2 decades of innovation, SafeSmart delivers modular stairs, mobile work platforms, edge protection, and customized access solutions for construction, industrial, aviation, mining, and infrastructure sites worldwide. Its lightweight, high-strength aluminum systems are built to meet global safety standards and fit every job, from adjustable stair towers to mobile platforms and workstations that eliminate dangerous ladders and unsafe makeshift access. Every unit is designed, manufactured, and quality assured with precision, engineered to improve safety and efficiency while cutting installation time and risk. Access engineered for safety, performance, and real-world work. This is Safety Respect Flex Working Platform, a precision-engineered solution that transforms how crews work safely at height, on facades, roofs, and structural edges. Built by Safety Respect, this modular platform replaces slow, bulky scaffolding with adaptable consoles and decks that attach directly to walls or roof structures, creating a secure, load-rated work surface certified to scaffold standards. Flex systems install fast and conform to complex geometries, giving workers a stable, engineered platform where traditional scaffolds can't easily go. Hot-dip galvanized components resist corrosion, load classes handle real site demands, and flexible configurations mean the platform adapts to walls, eaves, and roof lines without compromise. Designed for construction speed and site safety, it stops hazards before they start. Engineered for performance, precision, and protection. Work elevated, engineered for safety and strength. This is the Minic Barrier Wall Drill, a purpose-built concrete drill engineered by Minic Manufacturing to secure barrier walls faster, safer, and with precision on highway and infrastructure projects. This self-propelled, pneumatic drilling machine rides along the top of precast concrete barriers, aligning its bit through pre-molded openings and driving into the subbase with consistent, engineered accuracy, eliminating manual measurements and guesswork on every hole. Its air-powered motor propels the unit from position to position, while a tethered remote lets the operator control drilling from a safe distance out of debris and traffic risk. Designed to penetrate 1836 inches deep with robust drill steel. This drill cuts cycle time and labor, improving safety and productivity on site. Infrastructure drilling engineered for speed, precision, and operator protection. This is Sembla, a next-generation circular masonry system engineered in Germany to reshape how we build with concrete. Sembla is a precision-designed hollow block system made from low-carbon geopolymer concrete that eliminates traditional cement, cuts CO2 emissions by up to 70%, and integrates easily into modern planning workflows. Blocks lock together without mortar or glue, enabling rapid assembly and disassembly for reuse and adaptation across projects. No wastage, no demolition rubble. Its modular grid, built-in connectors for facades and services, and high fire resistance make it suitable for multi-story construction while preserving circularity from production to reuse. Sembla turns raw materials and industrial byproducts into sustainable, reusable building fabric. Circular construction engineered at every block. That's a glimpse into the power, precision, and innovation behind the machines changing our world. From FODS trackout control to Dinsel walls and Titan floor raised access flooring, these technologies don't just build, they transform. If you enjoyed this journey, make sure to subscribe, hit the like button, and share with fellow builders and tech enthusiasts. Stay curious, stay inspired, and remember, everything you see is just the beginning. This is Build